I think it's just about 20 slides, so that's mean we can finish our last class today early. All right. Before that, you need to understand why we apply the pre-stressed concrete. Okay, so the conventional is what we have learned before. That is the concretes that reinforce with steel reinforcements. But this pre-stressed concretes actually is a more enhanced technology that also can apply, uh, but need some expertise, equipments, and also concerns also about the cost. Okay, so as we know that the concrete is very good in compressions, right? But weak in tension. So it's about only 10% tensile strength compared to the compressive strength in a concrete. So that's why in the designs we just ignore the tensile strength of the concrete. So because of this weakness of the concretes, that's why we provide the steel reinforcements in order to take up all the tensile stress in the concretes. So that's why there will be a reinforcements, the main bar that we provide, that we arrange at the tensile regions. Okay. Um, um, it will enhance, okay, of course it enhance the strength of the concrete, but at the same time the cracks, the problems of cracks still occur. Okay, the problems of crack, either flexure crack or shear crack, is still occur, um, um, especially that is initially occurred at the bottom one. Okay, which is due to the bendings, um, due to the deformations once we apply the load to the structure. Okay, right. So the problem of crack is first is about its appearance, right? We don't want to have a cracks. It will give a negative aesthetics value, okay, to the negative appearance to the structure. But at the same time, the main thing is the cracks is which can lead to the corrosion problems, okay, especially for the steel reinforcements. Uh, that's the parts that's all the also chemicals or any moisture can ingress, okay, into the concretes. So the concretes also lead to failure under serviceability, lead to wait a minute lead to failure under serviceability limits here. Okay, so that's why in the design we control the crack widths, right? Okay, and then reduce the performance, either flexure or shear, because we have a shear cracks, we also have a flexure cracks. Uh, then what else here? Okay, of course, cracking is irreversible. Once it starts to crack, it will continue until to failure. So to solve the problems of these cracks, the deflections or deformations, even we already provide the reinforcements, uh, then the technology introduced the pre-stress here. That means we apply the pre-compressions, okay, to the concrete before it its begin its working life. Okay, so pre-stress can be understood that we apply the pre-compressions. That means we induce the compressions regions of the concrete because uh, 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 concrete put in compression. So that means in a simple words that need we want to reduce the tensions area, make it as also as a compressions area. So that means for the whole structure can resist the load. Okay, for the whole structure. All right, so if you look at here, this is the plain concrete. Okay, this is the plain concrete without any reinforcements. Look at how it performs, how it deforms, deflects, and due to the cracks here. Okay, that it start from the bottoms up to the top, that make it once we don't provide any reinforcement, it can be split up into two components here. So that's why we have to provide the steel reinforcement, which is still good intentions. So the combinations of concretes and steel um, can enhance the performance, can increase the uh, uh, load capacity for the reinforced concrete. But at the same time, cracks still occur, okay, because of deformations. Okay, um, although we provide the reinforcement, the deformation still occur. So because of deflections, the cracks occurs. So and will lead to other problems. Okay, what I've mentioned about the corrosions. Okay, about its during its serviceability, working life, and so on. So in order to reduce this cracks problem, that's when we have to fight with the cracks problem here. So that's why it introduced the pre-stressed concrete here, which is we apply the stress, we apply the compressions, okay, to the concretes. So this is all the things, the main thing that should be provide here, which is the reinforcements that we call it as a strand here or cables. Okay, one cables here have about 7 to 6 wire strands, okay, for each of these cables here. So you look at let's say for this box girder here, okay, especially for the bridge, okay, for the flyover, you will see this each point of the cables, okay, that it provides in the concrete. So this is the basic things that you need to understand. How do the pre-stress works? First, we have to stretch. Okay, kita kena tarik steel tu. Okay, and then release in order to transfer the load to the concrete. So you can just imagine, okay, like a rubber that we stretch the rubber until to certain lengths, certain elongations, and then we release the that rubber. That means we apply the stress to that structure, we tighten the structure, we compress. It's like we twist the objects. Okay, that means we transfer the load. That means that objects um, uh, more in compression state here. Right, so this is the basic things, okay, for the pre-stress process. If you look at here, this is once we compare between reinforced concrete, the conventional reinforced concrete, and pre-stressed reinforced concrete. Okay, so this is the reinforced concrete before we apply the load. Okay, of course there will be a reinforcement inside it, and then uh, in a state of unloaded here without any load, the structure in the planes conditions, in the planes positions here. Okay, but once we apply the load, there will be deformations that can induce the developments of the cracks. Okay, especially it will start at the maximum moments regions, okay, which is at the center, at the midspans of cracks, and then it will continues to propagate up to the shear regions and so on. Depends what's the designs that we provide for that beams. Okay, but once we compare with the pre-stressed reinforced concrete here, so this is the conditions or positions of the pre-stressed concretes during unloaded, okay, which is it in the states of upward deformations here. Okay, we couldn't see obviously, okay, by our eyes, but actually it have slightly deformations, okay, from the midspans to the ground surface. Okay, it's upward here because of load that we transferred, okay, after we release the cables, okay, that make this structure slightly upward, okay, from the ground level. So that means once we apply the loads, okay, that will make this pre-stretched concrete back to its original apa ni levels. Okay, it backs to its original level. It becomes flat. That means no cracks will occur. Okay, might be just a small cracks occurs because of the vibrations, because of the movements. Okay, but this is how the theoreticals, why we applied, why they come up with these kinds of technology. Okay, all right, so this is the other examples that showing loads from the vehicles, okay, especially for the bridge here. So because of the loads that this come from the lorry, because of the movings, vibrations, and so on from the transportations here, so the concrete will begin to bend, okay, when heavily loaded here. There will be a bending, of course, because it from the flat surface, from the flat positions, once we loaded, there will be a bendings, there will be a deformation due to the moving load here. So because of these deflections, you can imagine there will be a cracks occurred, okay, especially at the midspan here. Then by placing the reinforcement here, of course, it will increase the performance, the strength of the concrete, and hold together all the cracks, okay, from becomes worse, from becomes widen, and so on. Okay, by this pre-stress, okay, so uh, it makes the structure more stronger, okay, and also reduce the cracks here, okay, by stretching the road and release the roads in order to transfer, to squeeze the concrete, okay, to make it more stronger. All right, so for pre-stressing, it needs high tensions, steel reinforcements that we call it as a tendon. It consists of wire, strand, and also bar. Okay, but it should be in a high quality, in a high strength of reinforcement here. Also, it needs the equipment, especially for the hydraulic jacks here, in order to stretch, okay, in order to give in order to pull out uh, the steel reinforcements, okay, in the concrete. Uh, you can see here all the equipments that use here, okay. So this is the hydraulics jacks here, okay, that will pull out, okay, all the reinforcements. And then so after that there will be a anchorage here that will hold all the cables, okay. For pre-stress, it can be divided into two methods. Kalau you are familiar, we have a pre-tension and also post-tension. So you need to understand, don't confuse what is pre-tension and what is post-tension. So from the terms, you already can come up with the idea that it's pre-tension, that we apply the initial compressions, okay, before the structure can be used. Okay, for the post tensions, that means we apply the compressions at the ends of the castings. Okay, so that's why it use the terms here, pre and post. That means we apply first the compression, or might be we apply at the finals of the manufacture. All right, so pre-tensions here. So this is all the steps. Okay, if you look at this is how set up. Okay, for pre-tensions, which is at one end here, that we call it as the end abutment, which is this is the anchorage, the fixed ones, okay, that will hold all the tendons, okay. And then this is about the length of the concretes. There will be a formworks and so on. Okay, and at the another end here, that we provide the hydraulic jacks in order to pull out uh, the steel reinforcements, okay, and then also to release the steels, and then after that we have to anchor back all the tendons here. Okay, so the first step for pre-tension, that you need to stretch the steel reinforcements, okay, then hold it by the anchor, okay, by the anchorage. And then the second step, we do the castings, okay, we do the castings for the concretes, wait until it achieves its strength up to, might be up to 28 days, and after that we have to cut down the tendons, cut down the steels in order to release, and also at the same time we transfer the loads to the concrete, that make the concretes more tighten, and also have extra compressive strengths, okay, in the concrete here. Okay, so that's mean the first things, the first step, that is we have to stretch, um, we have to stretch, okay, the reinforcements. And then the second steps, do the castings, okay, do the castings for the concretes. And then the third steps, release the load, okay, or release the reinforcements, cut the reinforcements. That means we apply the loads, we tightens, we compress the reinforced concrete. Okay, so that makes a slightly deformations here. we couldn't see roughly, okay, but there will be a slightly deformations upward here, okay. Then after that, during its services, once apply the loads here, there will be a becomes a flat surface, okay. So that's mean there's no deformations, there's no downward deformation that can induce the cracks, okay, in the concrete. So this is all the equipment for pre-stress, which is it usually prepared at the factory. Okay, so if you can see here, depends the sizings, the lengths for the structure. Okay, this is all the structure that is prepared at the factory. Then it will be brings to the sites, and then arrange and connect it with other parts, okay, of the precast, that we also call it as a precast, which is some things or structure that is prepared at the factory and then brings to the site. So because of these pretensions, prepared or should be prepared at the factory, so there will be a limitations, okay, because of transportation. There will be a limitation, sizings, lengths, and also shapes, okay, and also shapes. Might be it can produce a standard shapes, standard lengths, okay, and also the way that is capable for the for transportations and so on. So that means there will be a limitation on this one. um, and but at the same time, it's quite easy because we just order all the size shapes from the factory, and then they will bring up all the structure, okay, and then we just assembles all the parts, okay, at the site here. So the second of pre-stress, that we call it as a post tensions, okay. For the post tension, it will be opposites from the pre-stress, which is um, we will apply the loads, we will do the stretch, release at the end of the productions of the concrete. So that means the first step, we have to do the casting, okay. We have to do the castings for the concrete, but inside it should be provide with the tube ataupun ducting, okay, in order to insert all the steel tendons, okay, into the concrete, okay. So during the castings, at the same time, should have a ducting, should have a tube, okay, for the hollow tube here. Okay, then we have to wait until the concrete hardens, until it achieves its strength. So the second step, then we apply the stress, or we stretch, okay, or we pull out this tendon here, okay, up to certain load, up to the certain elongations, and then once it achieves its design's requirements, so we have to cut the tendons. So that means there will be a transferred loads that will be released into the concrete here. Okay, so this is also the methods that we applied the compressions to the concrete. So that is the two difference between pre-tension and post-tension, which is the pre-tension, we stretch, we pull out the tendon first, we pull out the tension first, the reinforcement first, and then we do the concreting. Okay, but for the post tension, we do the concreting first. Okay, wait until the concrete achieve its strength, and then after that, at the final stage, we insert the reinforcements, do the stretch, and also release the load, transfer the load to the concrete. So that is the two difference between pre-stress and between the pre-tension and post-tension here. So this is all the works that it conducts for post-tension, which is more suitable to be applied at site. Okay, these ones mostly apply at site here. So that means there will be a unlimited size, unlimited shapes, dimensions, okay, for the structure can be prepared at sites, okay, because we don't have to consider about the transportation and so on. So for post tension, it's suitable to apply for the complicated structure, okay, such as for this box girder, okay, for any shapes, any forms of the structure, okay, compared to the pretension. So for the pretensions, it's suitable to be to use for the standards sizing, standards components for the structure. Okay, for the post tension can be specials for big structure that can't be transport, okay, that can't be transports, and also need a big scales of modes and so on, okay. But at the same time, for the post tension, it's more costly, okay, because we have to provide all of this tube, all of these ductings, okay, need to be inserted in the reinforced concrete, okay, compared to the pre-tensions. So you can go through, okay, in details about its advantage here. Of course, it reduces the cracking here, okay, compared to the um, conventional reinforced concretes. And then the entire concrete cross section also can resist the applied load, because we give additional stress, compression strengths to the concretes. Okay, so at the same time, it will induce the performance of the reinforced concrete, okay, compared to the conventional one. And the pre-stressed beam are longer, okay, okay. So that's why the pre-stress or precast usually used for the bridge, okay, that need a long spans for the girder, for the beams and so on, okay. All right, so for disadvantage here, of course, is about the cost, okay, high cost needed for pre-stressed reinforced concretes. It's not also for the steels, but also need need to use high strengths for the concrete grade, okay, and also need to have all the equipments, okay, like hydraulic jacks, equipments for the anchorage, okay, for the cutter and everything, okay, that is needed, okay, during the stretchings, during the releasings of the reinforcements, and also need skill labor, okay, should have expertise, okay, to do the process, okay, for this pre-stretched concretes, because it contributes to the high technology, okay, for the all the equipments, and also for the designs, for the pre-stress here. Okay, so of course, materials that is consists in a pre-stress should be a high strength concrete. Okay, depends the designs. Just skip here, and then also for the pre-stress steel here, if you look at here, this is the examples. Depends how many wires that is includes in one strand here. Okay, in the concrete there will be a more than one strands. Okay, that each of these strand here got about 6 or 7 wire. Okay, so overall the diameter can be up to 18 mm. Okay, for each of the wire here. All right. Okay, one more thing here. The ultimate strength. Okay, for the pre-stress steel here. About 1,800 megapascal compared to the conventional steel reinforcement, just 500 megapascal. So you can see the differences between it. Okay, that we need to use a high strength material, so that means it will affects also the cost of the materials to be used. And then this is the equipments, a part of the equipments. It need to have these hydraulic jacks, okay, that will stretch all the tendons to the certain loads. And also there will be a measurements, the elongations, okay, um, need to be applied, okay, at sites. And also need to have all these things of anchorage that will be pull and tightens all the cables. Okay, at the ends, all the tendons will be cut out, and then to fill up all the gaps between these tube here between the cables. Okay, we put some grouting here. It's like a epoxy. Okay, this is how once we do the cut section, we can see all the groutings that fill up at the ends. Okay, at the ends of the anchorage here. So this is all the applications for the pre-stress. Okay, can be for the water tanks, can be for the high-rise buildings, for the bridge, for the tunnels. Okay, all of the big scales projects. Okay, apply for the pre-stress concrete here. All right, so that's it. It takes about only 30 minutes. Okay, it takes about only 30 minutes in introductions for the pre-stress. So that means we finish our last class today, because it's just for the introduction. At the same time, you also need to understand about the pre-stress, the differences between two methods of pre-stress and post tension here, pre and post tension here. So so that means in order to know the design, so you need to apply for other subjects, okay, that consider about the designations, calculations for the pre-stress. So any questions for this topic? Lepas ni kerja boleh kerja dekat precast, concrete, so you will see all the process production for the pre-stress, how they pull up all the reinforcement, okay, all the reinforcements here, all the tendons here into the certain load, okay, into the certain loads, and then after that there will be a process for cutting all the tendons here. Nanti last ada masukkan sockets and everything, grouting and everything. Okay, that is the basic thing about the pre-stress enforcement here. At the same time, dia punya main bar also the same process. We have to arrange all the main reinforcement, and at the same time there will be additionals. Okay, a tendon here. Okay, for pre-stressed concrete. Yang lain-lain reinforcement still provide, but there will be additional tendon specials, okay, to transfer the loads to make the structure more into compressive strength. Okay. Okay, that's it for today. Kalau masuk final pun it more on theoreticals. Okay, there's no calculation for this one. Okay, for your finals will be on bila final? Siapa tahu bila final?
11.
11. Oh, saya baik tahu kan. Okay, so 11 Julai from 9 to 11:30, which is 2 hours and 30 minutes. Okay, so supposedly by 8:30 you all dah standby online. Okay, for this semester we still go for online assessment. Next semester not sure, might be we can go for physicals for class and also final test and everything. Okay, so untuk finals it take about 2 hours and 30 minutes. Generally you punya finals 3 soalan. Okay, 3 soalan, semua wajib jawab, perlu diselesaikan dalam masa 2 jam setengah. Okay, please be prepared, everything's done. Kalau siapa dah check, saya dah upload you punya test dalam Otter. You dah check ke?
Belum.
Belum kan? So markah test semua dah key in dalam sistem. You punya test pun saya dah upload semula dalam Otter, so you can check. Okay, alright, so any questions before I stop the class? Soalan?
Tiada.
Tiada kan, semuanya sonang belakang. Okay, so that's it for today. Good luck everyone for your test. Don't forget about your project. It should be submit by next week kan. I dah bagi extra times for you to finish all the tasks. For project 20 marks. Buat betul-betul. Dan attendance for today, I assume that all of you attend the class. Okay, so you don't have to submit attendance anymore. Okay, so that's it for today. Good luck semua. See you again masa final nanti. Bye. Terima kasih semua.
Thank you, Doktor.
Thank you, Doktor.
Okay.
Thank you,